restriction enzymes are classified into four classes: type 1, 2, 3, and 4. All types of enzymes recognize a specific short DNA sequence and carry out in the endonucleotide cleavage of DNA to give a specific double-stranded fragment with the terminal 5' phosphate. They differ in their recognition sequence, subunit composition, cleave position, and cofactor requirements. In type 1, these enzymes are complex, multi-subunit, combination restriction, and modification enzymes that cut DNA at random far for the recognition sequence. Type 2 produce discrete restriction fragments and distinct gene binding partners, and they are the only class used in the laboratory for routine DNA analysis and gene cloning. The type 3 cleave outside the recognition sequence and require two such sequences in opposite orientation, with the same DNA molecule to accomplish cleavage. They rarely give complete digest. And the last one, the type number 4, typically recognize methylated DNA. There are many programs of bioinformatics to use to cut DNA sequence with enzymes. One of these is NEPCODER, that we will going to use in this practice.
Placing a 0.6 ml microtube the reactive for the enzymatic restriction with enzymes separately and combined as indicated in the following table. Complete until 20 microliters in the same order as indicated in the table. And storage the sample at 37 degrees for 1 hour. Finally, run the samples in an agarose gel.
In order to be able to make the restriction, use the vector PCR topo. The digestion with 7 enzymes became the insert vector with insert, one war sense and antisense. With the help of the program, NetCoder was taken. Later, with the help of enzymes SHA and ESCA, one verified where a buffer worked variant, and it concluded that with buffer 3.1 to a temperature of about 37 degrees Celsius. Finally, with the help of the electrophoresis in agarose gel and electrophoresis in silic, obtained the following results. For plasmids, white. In the well 7, this was cut with ESCA1. 3 bonds are shown. In this case, one only bond has to be shown because enzymes only cutting one part of the plasmid, causing the linearization. But these results indicate that enzymes didn't cut the plasmid. In the well 8, only one band is observed. In this case, the restriction enzymes cut the plasmid and linearized it. In the well 9, 3 bands can be observed. That indicates that the two restriction enzymes perform the cuts in the right regions. According to the electrophoresis and the restriction map generated before the practice, the plasmid white has the insert in the same position because the well 9 showed 3 bands that correspond to the cuts that the two enzymes perform in the plasmid according to the restriction map. For plasmids blue, in the well 3 one band can be observed. In this well, the plasmid was cut with one restriction enzyme, ESCA1, so the plasmid is linearized. That is why only one band is shown. The same happened in the well 4, where the plasmid was cut with SHA1. In the well 5, the plasmid was cut with two restriction enzymes, ESCA and SHA. So 3 bands has been to show, because the two enzymes cut in three different regions of the plasmid, and this produces 3 bands.
Like all enzymes, a restriction enzymes work by shape-to-shape matching. When it comes in contact with the DNA second with a shape that matches a part of the enzyme, called the recognition site, it wraps around the DNA and causes a break in bond strands of the DNA molecule. Its restriction enzymes recognize a difference and a specific recognition site, or DNA sequence. Recognition sites are usually in only short 4 to 8 nucleotides. Restriction enzymes are basic tool for biotechnology research. They are used for DNA cloning, get information sheets, and DNA fingerprinting. Digesting a DNA substrate with two restriction enzymes simultaneously is a common time-saving procedure. Restriction enzymes digestion takes advantage of naturally occurring enzymes that cleave the DNA at a specific sequence. There are hundreds of different restriction enzymes, allowing scientists to target a wide variety of recognition sequences. Restriction enzymes digestion is a commonly used technique for molecular cloning, such as cloning by either PCR or restriction enzyme digest. It also used to quickly check to identify or a plasmid by diagnostic disease. To obtain an enzymatic restriction, it's necessary to consider the quality and the quantity DNA. The quantity of the enzyme, the DNA cannot contain cells, ethanol, or phenol because these factors can be affect the catalysis of enzyme acting, like inhibitors. Other factor crucial is the glycerol concentration. This is so important because high concentration can be elicited star activity. The most important steps are the recognition sites can contain the sequence of DNA to the ligation to show the enzymes to do the digest. The time of incubation, usually for 1 hour, storage to affect as little possible. Keep the stability and the reaction control. In this result, we obtain insert in the plasmid according with the electrophoresis that show 3 bands to the corresponding cuts.